density-based spatial clustering of application with noise. This is a density-based clustering algorithm that works on the assumption that clusters are dense regions in space separated by regions of lower density. It has a high performance rate for a dataset where clusters have the constant density of data points. One of the significant attributes of this algorithm is noise cancellation. It groups densely grouped data points into a single cluster. It can identify clusters in large spatial datasets by looking at the local density of data points. The most exciting feature of this clustering algorithm is that it is robust to outliers. It does not require the number of clusters to be told beforehand, unlike k-means, where we have to specify the number of centroids. Binning discretization. In this method, the data is first sorted and then the sorted values are distributed into a number of buckets or bins. As binning methods consult the neighborhood of values, they perform local smoothing. This binning method can be used for discretization. It takes as input a set of continuous values, applies the discretization, and gives us output a set of discrete values. The attribute values can be discretized by applying equal width binning or equal frequency binning, and then replacing each bin value by the bin mean or median or by the boundaries, which is smoothing by bin means or bin medians or smoothing by bin boundaries respectively. Then the continuous values can be converted to a nominal or discretized value, which is the same as the value of the corresponding bin, which we will look at in the upcoming slides. Types of binning discretization: equal width or distance binning. This is the most common form of binning. It partitions the range of variables into k equal width intervals. The interval width is simply in the range a, b of the variables divided by k. It is given by the following formula. W equals b minus a the whole divided by k. Thus, the ith interval range will be given by the set of values a plus I minus 1 into w and a plus I into w, where I is a range of values varying from 1 to k. Skewed data cannot be handled well by this method. The second type is equal depth or frequency binning. In equal frequency binning, we divide the range a, b of variables into intervals that contain approximately equal number of points. This is a less commonly used form of binning. Each bin does not have equal width, but each bin does contain an equal amount of observations. Equal frequency may not be possible due to repeated values. Smoothing of data using binning discretization. There are three approaches to perform smoothing. The first one is by using bin means. In smoothing by bin means, each value in a bin is replaced by the mean value of the bin. Mean is obtained by adding up all the values and then dividing that total number by the total number of values in the range. The second one is bin median. In this method, each bin value is replaced by its bin median value. The median value is obtained by taking the value lying at the midpoint of the frequency distribution. The third type is by using bin boundaries. In smoothing by bin boundaries, the minimum and maximum value in a given bin are identified as the bin boundaries. Each bin value is then replaced by the boundary value that it is closest to.